The solution of this question goes this way. We have a piston cylinder arrangement. This is my cylinder and this is the piston. Piston cylinder arrangement is there, and we have to find the network transfer for the system. We have given atmospheric pressure. P atmosphere is given out to be 101.3 kilopascal. And we have been said that there is a steering device here. Suppose it is my steering device and the piston is frictionless and held against the fluid with the help of atmospheric pressure. Steering device. Now since it is a steering device, therefore it will do the rotations. So we have been given number of revolutions. We have been given this value, number of revolutions, that is N is 9500. Torque is given. Average torque, or simply say torque, is given out to be 1.25 Newton meter. Torque is denoted by T. And the piston diameter is given, small d, 0.65 meter. And the distance moved is also given. Due to the application of pressure, the distance moved by the piston is 0.6 meters. If you see, the work is done at two places. This steering device is doing work, and due to the pressure, the work is done on the piston. So we have to find two work done. That is, the total work done will be summation of W1 and W2. If I say W1, that is work done by steering device, is 2 pi nt. We are using this formula, that is work done is omega t, work done or say power omega t, which is 2 pi nt. Substituting the values, N is 9500 and torque is 1.25. On substituting these values, we get the value of work to be 74.613 kilojoule. I have converted it into kilojoule. And now since work is done by the system, considering steering as the system, work is done by the system. Therefore this work done is negative, minus 74.613 kilojoule. Because we have the sign convention, work done by system is negative, and work done on system is positive. This is the sign convention which I am using. Now second work done on the piston. Since the piston has moved, so the force has acted on it, Fdx. Work done is Fdx. If you remember the previous things, or even if you don't remember, if there is a force and displacement is taking over at that place, work done is Fdx by the work energy theorem. Force is pressure into area into dx. Substituting the values, 101.3 kilopascal, and area is pi by 4 d square. Since it is cylindrical, diameter is 0.65, into dx is distance moved. See, meter square, kilopascal per meter square. Work done comes out to be 20.169 kilojoule. What is the total work done? Simply summation of W1 and W2. I have added these. Calculating this expression, answer comes out to be minus 54.444 kilojoule. The net transfer of work is simply the magnitude of this value, because transferring something is never a negative. Transferring is never negative. Negative sign indicates that work is done on the system. This work is done on the system. Work is done by the system. I apologize here. Work is done by the system. By the sign convention you can see over here. You should not get confused. This is the sign convention. Work done by the system is negative and work done on the system is positive. Here work is done by the system. That is why it is negative. And the net transfer, since negative value doesn't come, so we have to take the modulus and simply write this value. This is the net transfer. This is the required solution of the given problem. There are other engineering problems also on my channel. You can visit them and solve them